Thanks for attending this session. This is SOQL query performance tips and tricks. So it's day 4 at Dreamforce. So everyone's seen this. You don't need me to read it. Make your purchase decisions, obviously, on current feature set, not anything we talk about. So hi, I'm Chris Bland. I've been working on the Salesforce platform for around 5 years now. In my time, I've used to manage the CRM implementation for Groupon. So I've worked with very, very large data sets, 12,000 users, millions of rows. So querying and managing large data sets has been something really important to me. It's something I've learned a lot about in the last few years, and I'm here really to share that information with you. Currently, I run my own ISV, so I'm working on building applications for sales performance and performance management. If you want.
Hi, my name is John Tan, and I work in the customer-centric engineering team at Salesforce. I get involved with a lot of customers with large data volumes, and query performance is one of the key things that I help customers with.
Perfect. So before I start these sessions, I always like to get a little poll of the audience, like to see sort of who we're dealing with here. So developers, raise your hands. All right. Admins in the crowd? Couple. Any business analysts? Okay, perfect. Start with that. So first off, I know you guys see this slide normally at the end. I would like to start off by saying thank you to the Salesforce technical team. This is one of my favorite features that they've come out with in a while. For me, it's one of the most powerful ones. It's one I've been asking for a few years. So I'd like to thank Salesforce for coming out with this. This is huge. So do you guys have a query problem? Right? There's a silent killer lurking in your orgs right now, and it's really hurting your adoption. And that's query performance. So what's that mean? These are some of the symptoms. Do your users ever complain of slow or unresponsive reports? Dashboards taking a while to load? List views that just take forever and spin? Slow, unresponsive Visualforce pages? Maybe it worked in the beginning, but now it's a year later, and it's taking a little bit longer, and your users are really starting to complain. And that's the last thing we want as developers. We want our users to love using Salesforce. We want this to be the tool they go to. Or have you ever had problems with the data loader, where it used to take 5 minutes to update 10,000 records, but now it takes 3 hours, and you're sitting there and waiting and waiting and waiting. So if you've experienced any of these issues, who has? Perfect. You're in the right session. You may have a SOQL problem, but have no fear. We're going to optimize it today, and we're going to show you a lot of tips and tricks on ways to optimize your queries, your reports, your list views, everything there. So prior to the release of the Explain tool, which we'll get into in a little bit later, this is sort of how Salesforce used to work, at least in my eyes. I would write a query. I would send it in. I'd run my Apex. It would go into the black box of Salesforce, and then I'd get my output. Sometimes it would take longer. Sometimes it would be quicker. You didn't really know why. You couldn't understand it. Some users would complain, hey, this report's taking a while. You would go run it, and it would run fine for you. So this is the prior state of Salesforce, and this was a big pain point for me. Currently, though, we have the Query Optimizer. So what is the Query Optimizer? Underneath Salesforce, there's a database. It's running basic SQL. But to access that database, you need to talk the language of the Force.com Query Optimizer. And even if you're thinking, oh, I'm just running a report, I'm using a list view, I'm not writing SOQL, you are talking to the Query Optimizer whether you know it or not. If you want to get data out of Salesforce, you need to talk to the Query Optimizer. So what does the Query Optimizer do? The SOQL Query Optimizer, its main job is to take your raw SOQL that you generate and turn that into something that the underlying database can understand. So you want to run the most efficient queries. But Salesforce is a multi-tenant platform. So there's a lot of different things that are happening here. What happens with sharing rules? Right? What happens to an Apex class with or without sharing? All of these things need to be optimized. In addition, Salesforce will do things like pre-queries, and they'll dynamically build statistics for you overnight to help you optimize your queries. And Salesforce will take all of that in the Query Optimizer and figure out what is the most optimized SQL to run. So for everyone who doesn't know, SQL is the underlying database or underlying language to query the database at the raw level. You never interact with SQL, but Salesforce will interact with it for you. So what's an index? I like to start here because a lot of developers are a little new. They don't really understand what an index is. So the easiest way is a database table index contains a copy of a certain column of the table and pointers to the location of that column in memory. So this is normally stored in some specific way. And the way I like to relate this to people is think about looking up a dictionary. Right? If I wanted to look up the word cat in a dictionary, how could I do it? Well, I could open up the dictionary, go to page 1, and start with A, keep going down until I found cat. That's going to take a long time. So what can you do? You have an index at the back where you can say, I can look up, oh, see cat, it's on page 157. It's a lot quicker. The information isn't all there, but it gives you that pointer to go right to your index so you know where to go. So what fields are indexes in Salesforce? This is going to be really important as we start to build queries. You want to know what fields out of the box Salesforce has indexes on that you can use in your queries. So let's start just going over some of these. The record ID. So anytime you query based on a Salesforce record ID, that's a pre-provided index from Salesforce. It's going to use that example that we talked about, using the dictionary. It's going to find that record ID and go right to the memory location. It doesn't have to scan all your data to figure out where it is. It knows exactly where it is from the record ID. Any field that's marked as an external ID. So you know how when you create a field, you can mark this. It's an external ID. That's going to be indexed for you as well. The name. Last modified date. Created date, and we'll get into how you can use some of these and why they're important in a minute. Record type ID. So if you're querying for opportunities and you're using record types, when you write your queries, you're going to want to use record type ID. You're going to want to be very, very specific in your queries. The more specific your queries are, the more performant they're going to be. For those of you using division, division is a great way to segregate data. So if you're using a division filter and a where clause in your query, Salesforce is going to say, oh, I know exactly where that data is. I only have to look at this small subset of data. I don't have to look at all of your table. I can just go simply right to the division and use that. And email. This is one that I don't think a lot of people know about. Email and the contact and lead object are going to be indexed for you, which is great. So if you're looking up things in Visual Force pages for contacts, you want to build a little Rolodex on the account page, very specific ways to do it. And any foreign key relationship. So anytime you create a lookup or a master detail, that's automatically going to be indexed for you as well. And the best part about all of this, it is 100% free from Salesforce. They give us all these great features out of the box. The problem is not a lot of developers are using these when they write their queries. So I'm going to pause here and say, if there's one thing I want you to take away from this session, it's to use an index and use it often in your queries. Use an index and use it often. It's the easiest way to simplify and optimize your data. So you just heard me say indexes are great, but indexes can be bad. So don't leave the session, call your Salesforce rep and say, I want an index on this field, this field, this field, and turn everything into indexes. You can actually run into a lot of problems with that. So why don't you want to index everything? Well, what happens if you have a lot of records pointing to the same index? So let's think back to that dictionary and cat example. What if in the back of the index, instead of one lookup for cat, you had 12 different pages of cats? So it said, oh, it's on page 42, it's on page 65, it's on page 95. That's bad indexing, right? It's going to take longer to go through and look up to see if that's the data you want than if you've just done a table scan and gone over it. So what else can happen? You can have what's called index skew. So I see this a lot of times with customers where you'll have a lead object and you'll create a holding person, right? So you dump all the leads that no one's working and you assign them to that person. Well, now you've got an index full of this one column. So your entire index is the same ID. So all of a sudden your queries are not going to be performant. There's not a good way to look that up. And so the amount of index skew is going to be very important to the optimizer when making selectivity decisions. So if you have a column with a lot of index skew, the query optimizer is going to go, oh, I don't know what to do with this. I'm just going to scan everything and find your data for you. The other thing that can happen here is what's called index row lock. Has anyone ever had an unable to lock row issue with a database update? That's one of the most painful updates ever, right? It just kills you. So what happens there? When you go to update it, say two things are updating it at the same time. Under the covers, you have to rebuild that index every time it updates. So say that lookup changes. You have to go rebuild that index so you know exactly where to query the next time. Well, if your index is so large and you have so many records pointing at this one, when it goes to rebuild that index, you could end up with row lock underneath the covers. Even if two records aren't updating the same record, or two people aren't updating the same record, If they're both pointing at a large skewed index, you could end up with row lock, and that is really, really bad. So when you think about indexes, you really want to do it and plan carefully, which leads us to our next one. For your development lifecycle, I want everyone here to make query planning part of your development process. So when you're thinking about how do I write queries, you can't just be thinking, oh, what kind of query do I want? What's the data they need to see? Okay, I'm going to write that page. With Salesforce, you need to start thinking about what does my actual data look like under the covers? How many rows are in this table? Right? If you write a query, it may work really well in your developer edition when you have 5 rows. But what happens when you get to production and you have 300,000 rows? Right? That same query won't be there. So if you don't create a plan for writing efficient queries and you don't review this plan often as your data changes, you could end up in a lot of trouble. And what happens when I see this is people end up, you create a page, you create a workflow, you create a list view, you create an Apex trigger, and everything goes fine for the first year, right? Everything's great, you just sort of sock it away, it's just working, you don't have to worry about it. Well, a year or two goes on, you're really rocking Salesforce, you're creating all these new leads, all these new opportunities, and all of a sudden those reports and those dashboards that used to be really, really fast start to slow down. And you don't really notice it right away. It's a slow, gradual progression. But pretty soon, you're saying, oh, what is this? Why is this taking so long? And your users start to complain. And when your users complain, that's when bad things happen. They're going to be less trusting of tools, and they're not going to want to use Salesforce. As developers, we want them to love the platform. So just because you write a query when you're developer org, you need to look at this in a full sandbox. So for those of you with the upper levels, you'll get that full sandbox, and you want to run these query tests in there. So when can the query optimizer be used? So just because you have an index doesn't mean it's going to work. So let's say you have, a list of or a set of opportunities, and you have 1 million records, and 500,000 of them are closed won, and you're thinking, I saw that session at Dreamforce. Chris said, hey, use an index, and it'll be fast. And you're using it, and you're saying, that guy was lying to me. It's not fast. So what happens is the query optimizer will only use that index if you meet selectivity thresholds. So what is a selectivity threshold? That means the where part of your select statement, or your query, needs to match the first 30% of the first 1 million records. So in our case that we just talked about, if you have 500,000 closed won opportunities, even though you're using an index, Salesforce is going to say, I know you're using an index, but it's quicker for me to just scan everything because you have half the data as that index. And then you also, for large data orgs, you need to meet 15% of all records after. So again, you can see the Force Query Optimizer for standard index. So standard indexes are what we talked about a little bit earlier, those ones right out of the box. Salesforce also gives you the ability to make a custom index. So a custom index is going to be a little bit different. That's where you set external IDs, or when you've talked to Salesforce and you said, hey, I need this column to be indexed for performance reasons. It's a little bit different there. You have to meet the first 10% of the first 1 million records. So let's say you use that same example. You have 1 million opportunities, and you have 120,000 with a field that's indexed. It's not going to be selective. It's a custom index. So this is where planning really comes in. You need to think about what's the state of my underlying database. How many rows are there that are going to match this condition? And then you have to think, in your wheres, are you using a standard index or a custom index? So once you've figured out this and you've been able to drive this, Salesforce is going to pick what's called a query strategy. And query strategies can be broken down into 4 ways. The first is an index, and that's what we've talked about so far. The query will use an index on that. It's great. That's what you want when you see that. Then we'll go to the far right, a table scan. That's the last thing you want. That's the example where you have to go through the whole dictionary one by one until you find the right records. That's going to take a long time, especially in really, really large volume orgs. So those are sort of the 2 you hear about. If you come from a SQL background, you sort of know these. But there's these 2 in the middle that are sort of new to people who are new to the platform. One is called sharing. So Salesforce is going to say, because we're a multi-tenant platform and because there's sharing rules involved in your org, I know that I don't need to query all of your opportunities, even though there's 1 million there. If you're using an Apex with sharing class and you have sharing turned on, that user may only have 200 records. So Salesforce is going to say, I'm going to look at the subset of records that this user has access to. So again, when you start planning your queries, you need to think about who's using these queries and who's going to be running them. This is also how you can end up with different situations where the same report or the same visual force page might run different for two different people. So as a system administrator, if you're seeing all the records, that page may be slow for you, but for the end user, it's really fine. This is a really hard bug to track down. Sometimes reports and dashboards will be slow for one user and not for the other. And you'll go over and talk to that user and say, you know, I don't see the problem here. I don't see how this is working. And that's a big issue. Another one that you'll see that will come up is called other. And that's why we have John here as well, who can help explain what the other is when you're using the query performance tool. So now we're going to get into some common pitfalls when you're optimizing your query. So we want to write really, really selective queries. So how can we do that? How can we make sure we're, one, using an index, two, we're underneath the threshold, and that we don't do anything stupid? So the first one, how many people have ever written something that says, select ID from account where blank not equals to something? Right? You use not equals. You are now not using an optimized query. Whenever you're using not equals, your query will not get optimized. Salesforce is going to go, nope, I'm going to table scan this. So that's a big issue, and a lot of developers miss that. So you stop using not equals. And this is, again, where we want to go back to planning. Planning is the most important part of this. What records are you actually looking for? So in this case, we have some examples here. We have 100,000 records, and here's where they're broken up. So where is closed is not equal to true, wham, right away, not equal to true, not going to be optimized. So that query is going to run slower. So you have to start thinking, what did the data really want to show? In this case, you were just looking for stage name as prospecting and qualification. So now that we're saying, okay, we know what we want to filter on, but are we selective enough? So in this case, let's look how many leads are how many opportunities are prospecting. 15,000. How many are in qualification? 10,000. 25,000, that's going to be below the 30% threshold. Awesome, we're going to be selective there. Now you can see how this would start to run into some issues. What if I said closed won and prospecting? Uh-oh, just ran into an issue. We're not selective anymore. You're using an index. You thought you were using it the right way with using in, but all of a sudden you've got too many records in there. So again, you really need to start thinking about, what is the state of my underlying database? So what other common pitfalls do we have? Wildcards. Who's written things with wildcards in there? Not optimized. Sometimes when you're using these, maybe SOQL is a better approach. I know it's really easy to do a wildcard there for autocompletes, things like that. However, SOQL might be the better option for you. I know it's a little bit tricky to switch between two technologies in one page. If you're looking for optimized things, this might be the way. You want to use Salesforce's built-in search. So what I always like to say is you want to stand on the shoulders of others. I don't like to build a lot of work and redo things that have already been provided for me. Salesforce does a great job with search, right? They know how to do that. You don't want to have to try to do this matching stuff. You want to let Salesforce take care of that. The other common issue that you're going to see, so for the admins in the room or any developers building list views, how many people have used contains? Contains and list views are automatically not going to be optimized. So when you have that list view and it's running slow, all of a sudden, wham, you have contains in there. So start thinking about better ways to optimize and view your data, especially in list views. How many people have seen list views where it says 1 to 10,000 plus records, right? That's a really bad experience for your users. Odds are you built that view at one time for them, and there may have only been 100 records and it worked. But really, you never got around to updating it. And now all of a sudden, 2 years have passed, you're rolling out Salesforce, you're closing deals, but now you've got 10,000 records there, and it's slow, and your users start to complain. That's really what we want to avoid. So again, when you go back to things like list views, reports, you want to plan for these things. You want to plan for what's the future state of my database as well as what's the current state. So when someone comes up and asks you for a new report, start thinking about how many records are going to be in here next year. How many are going to be here in 2 years? Because if you're building these reports, you don't want to constantly be playing whack-a-mole chasing this stuff. You want to do it right the first time. The other common pitfall we're going to talk about is avoiding nulls. Who's seen code like this? You're going to select something, you're going to find a custom lookup field from the opportunity, you're going to iterate over all of them, and you're going to add them. So what happens if that lookup field's blank, and you just added a null value to that list? Right? This is very, very simple. You think, oh, I'm using an index, I've got it, everything's good. You've added a null value into this list, wham, not selective anymore. So you can see how easily it is to do this. So a simple way to fix this is check to see if that custom lookup field is null. If it's not null, add it, because you know that you're not going to have to need it for whatever operation you're going to do later. So this is really simple things that'll really catch you. How many people know that you can do formula fields and use index on formula fields? No one. This is a very little known fact. So you can index formula fields, but there's some common gotchas, and we're going to talk about those here for a second. So when can't you use a formula field? When it's going to reference other entities. So if you're going to do a lookup to another table, you're not going to be able to index that. If you use a dynamic date or time functions, so if you have a formula field that says, days since closed, you're not going to be able to provide an index on that because it's going to change and the value is going to mutate every day. You as well can't do whenever you're referencing the owner, auto number division, or audit fields. Same thing with currencies in a multi-currency organization. There's no way to provide an index when that value can change based on the end user. Binary fields and long text areas. Some of the special standard fields you also can't. So if you have a formula and anywhere and it's going to reference these, you're not going to be able to get an index on that field. So some of the ones: opportunity, amount, total opportunity quantity, expected revenue, is closed, and is won. You're not going to be able to reference those in formula fields if you want them indexed. Obviously, you can see the rest there. So now that we've talked about some of the ways to write queries, you're probably thinking, well, how do I know if my queries are performing? And that's where we're going to introduce the explain param into your queries. If you've ever written a REST query to Salesforce, you've seen something like the top one. Whatever your API version you're looking at, query, question mark, Q, and then you drop your text string in there. So if you've already written this, you have about 4 letters that you need to change, and you're able to fix this. All you have to do is change the Q to explain, and you're going to run your queries. And what that is going to do is that's going to give you the performance. Salesforce is going to return to you an object that looks something like this. And this is what you're going to get back from Salesforce when you use that explain param. Use that exact same query you're writing right now for maybe your bulk jobs, data integrations, things like that. If you want to understand it, you're going to get this back. Salesforce is going to return to you all the possible plans that they could use to find that data. So again, there could be more than one way to find the data. Salesforce is going to give you back this object. So let's talk a little bit about what you're going to get back. You're going to get back what's called the cardinality. So this is going to be the estimated number of records that that operation would return. So it's going to be an estimate. It's not going to be, don't look at this number and say, oh, it's 4,000 here, but if I run a report, it's 6,000, right? It's going to be an estimated number. Then there's going to be the S-object cardinality, which is, again, the approximate record count for the query object. So this is how you can know how many records am I querying, so you can find out if you're meeting that selectivity threshold. This is those numbers that we talked about earlier that you want to figure out, am I under that 30%? Then you have the leading operation type, and this is the cool one. This is the primary way that Salesforce is going to choose to run your query. And we just discussed these. You can have an index, the other, sharing, or table scan. So Salesforce will tell you, if you ran this query right now with these exact parameters, this is how I'm going to find your data. So it's not going to guess. It's going to say, if I ran this query right now, that's what you're getting back. And the last one you're going to get back is something called relative cost. And that's the cost to run the query compared to the object's query selectivity threshold. So for this, you want to be thinking low numbers. This is like golf. Lower is better. And your number has to be below 1. If your number is above 1, it's not selective, and it's going to go back to a table scan. And that's bad, right? You don't want to go through all the records to find your data. So these are the numbers that you want to be looking for when you're checking out your queries. So how is cost determined? Right? So the cost value is derived from the latest database statistics. So once a night, Salesforce goes through and will calculate database statistics for all of your objects. So Salesforce does this under the covers. This is sort of like helper methods for the query optimizer. So it can say, how many records are in this? How many things are in that? So something's going to happen here. You could change records overnight. Right? You could load 50,000 records in today, and it's going to change how your queries perform. So again, the plan with the lowest cost is the one that's going to be used. Anything above 1 is not selective. So what happens when you're doing this explain param and more than one filter is selective, right? You've figured out that, oh, I'm going to use close date, I'm going to use stage name, and a few other indexes. How do you know what Salesforce is going to do? Well, Salesforce is going to pick the one that's going to run the fastest. This is why Salesforce is awesome. They're going to solve this problem for you. It's going to say, I know based on my pre-computed query stats that you have this and that, and it's going to return the right query to run it. So what are some other common pitfalls that you may think of when you're running this? Something that might be different between a full sandbox and your production instance. How many people forget to empty the recycle bin? The recycle bin is a big way to screw up your queries. You may run a report and say, oh, I think there's 50,000 records, but you deleted 50,000 last night as well. So when you're running these queries, Salesforce is actually going to do 100,000 records, and you're not realizing that because you're looking at your report numbers. So there's two ways to solve this. On every object, standard and custom, you're going to have this isDeleted field. And isDeleted, you just set to false. It's a quick and easy way to exclude things from your recycle bin. These are small things that really start to add up over time. So again, when you're planning this stuff, are your records going to be deleted? Do you have a batch job going through every night and removing some of your records? The other way is empty your recycle bin. But if you try to get your users to empty their recycle bin all the time, that's like herding cats, and it's never going to work. You're going to constantly be training users and chasing it down. So always be thinking, how can I write the most selective queries? So next thing, because we're on time, I'm going to run through a couple little FAQs here, things that you might run into. So like we said, under the covers, there's an Oracle database. So does Salesforce use the standard Oracle optimizations? Again, no. We've already talked about this. We know that Salesforce is a multi-tenant platform. Salesforce is going to pre-compute statistics for you, as well as take into account sharing rules, things that don't happen in a normal database. So how often are those query statistics generated? They're going to be run once a night. So sometimes your data will change. It may take a while to figure this out, where you're figuring where the records are and what your tables look like. So Salesforce also does dynamic pre-queries. So if you ever run into the issue where you run a query once and it's really slow, and then you run it about 5 minutes later and it's a lot faster, and you're sort of scratching your head, why is that happening? Salesforce will do dynamic pre-queries, and they'll start caching the results for you. So and that cache will last for 1 hour. So when you run that query the first time, it's a little bit slow. The second time, it's going to be fast. This is also why when you run the report in the morning, second time you run it, it's fast, but then later in the afternoon, it's slow again. So how can you do that? How many values can you include in an in clause? This is a common question I've seen. You can use as many values in an in clause as you like, as long as you stay within the Salesforce SOQL character limit, which is 20,000 as of currently, I believe. So is the external ID a standard or custom index? So remember we talked about standard and custom indexes because they matter for selectivity threshold. So external IDs are going to be custom, right? So that means you need to be matching that top 10%. You're not going to think 30. So again, we want to be planning for what this is. So are all fields marked as unique indexed? Are they automatically indexed? Yes, they are. Salesforce is going to take care of this stuff for you. Can you add an index to datetime fields that are custom, that aren't created date? You can, but you have to contact Salesforce support to do that. So can you add an existing column? Again, you need to contact Salesforce support, but if the field's a text field, you can mark it as an external ID. Again, that's going to make a 10% selectivity threshold, but we don't want to be marking everything as external IDs, or we might run into that index row lock and index skew issue we talked about earlier. So again, be thinking of the bigger picture. And then how long does it take an index to be added once you've done this? Same with query selectivity. It's going to all depend on the number of rows you guys have in your database. If you have 10,000 rows, it's going to be a lot quicker than if you have 5 million. So you want to be thinking about this stuff. So right now, we're going to get into 2 quick demos where we're going to dive in and start querying some of this stuff. So let's do that. So first, we're going to start off using the developer console. So how many people use the developer console on a daily basis, right? It's a great tool, and it's constantly getting better. One thing that you probably didn't know that just came out is you can actually use this query explain param in your dev console. So you have this tool available to you right now. So I'm going to show you how to enable it. Just drop up here to help. Go to your preferences. Let me make this a little bit bigger for you. And see this enable query plan. Just set this to true and save. And now all of a sudden, you're going to be able to do this right now. You can go home in your org and start doing this today. Start profiling those queries. Think about queries as also reports. If you have reports that are running slow, translate them into what looks like SOQL, run them here, and you'll find out if they're selective or not. So you can do this for list views, reports. You just want to translate it into SOQL. So let's start looking at some of these. We're going to just say select ID from opportunity. And we're going to say query plan. So what's that say? So we've got a cardinality of 40,000. We're going to use a table scan, and that relative cost is 2.8. So that's a high cost. We don't want to write queries like this. This is an unrestricted query. Salesforce gets really mad about this. So 2 years from now, when your queries are unrestricted, there may be 10 million rows in there, and that query is going to bomb out on you. So if you don't have where clauses in your queries right now, in all of them, you want to go back and do that. So we'll see the S-object cardinality is the same as the cardinality, which means the number of records in this table is going to be the same as the number of records that we're going to return. So let's start working on this to see how can we do this? How can we limit this? So where stage, let's add a stage name, closed one. So now let's look at this query plan. So we saw that our cost dropped a lot, but we're still above that one threshold, right? So this is still going to use that table scan, right? We thought we were using an index, but apparently not, right? This is where this query performance tool is really going to be key for you. So you're probably thinking, if you're doing math in your head here, well, you said it's 30%, I'm seeing 6,000 and 40-some thousand, why is this not happening? So a little issue I ran into yesterday during a different session, I ended up throwing a bunch of records in there. And then I didn't delete them before the query performance tool ran at night and recalculated my statistics. So right here, if you're looking at this, you might think, this should be using an index. It meets all the criteria, and tomorrow it will. That's the issue. I had records in there tonight. When it pre-cached and pre-compiled all these statistics for me, it said, oh, nope, I'm going to use a table scan for this. So these are some issues. So how can we get this down? So let's start thinking about, what do we really need, right? We really only care about the last 200 opportunities that were closed. So we'll say order by close date limit 200. Boom! You've now dropped that selectivity all the way down to 0.01. And these are not directly related, so don't think that this query is going to run that much faster than mathematically versus a 2.8. It doesn't work like that. It's really just there to tell you how selective your query is. So if we look at this, we can see that the cardinality, we know that we're only limiting it to 200 records. So we've told Salesforce, go use this index, which is close date, and it's going to say find the last 200 and then stop. So Salesforce knows I only have to get 200 and then I can stop. So it's going to be very selective and very performant. These are a lot of different ways that you can run your queries. So I've got a couple examples here, and this is actually open source if you need a mobile component. So what I've done here is I've created a tool that allows you to save your most important queries. Queries that are run a lot, say for reports, and you can then come in and profile them whenever you feel like it. So we can say, run this query, and it's going to do this and explain it for you. So you can actually take this tool right now, and the link will be provided after, where you can save your queries and just run them whenever you feel like it. You can come in on a Monday morning and just check your queries. Make this part of your weekly development planning or monthly development planning, but always be thinking about your query performance and save them. It makes it really easy. So again, we can use any of these. So now let's get really specific. So specificity is the key to selective queries. So in this case, we're going to find everything where the amount's less than 5,000, it's greater than 0, its created date was less than today, and we're going to order by created date limit 200. We've found a very specific query here. And look at that, 0.02. So start thinking about, what do your end users really want to see, right? What data are they looking for? Let's be very specific in the queries that we're running. It may take a little bit more time developing up front, but in the long run, I promise you that it's going to pay off. Perfect. So I'll pause here for a second. This is my GitHub. You'll be able to go download this tool today, add it to your org. I'm going to add it to a managed package as well so you can have it. And it is Salesforce 1 mobile enabled. We all know that mobile is the key. So I can run that exact same query performance tool on your mobile one app. You can be sitting there with someone who says, oh, this is slow. You can pull that query up right here, run it, and get the results right on your mobile phone. So when you're sitting with one of your internal customers, you can profile things right with them. These are some key things that you want to be thinking about. So now with the last 5, here's some additional resources. There's a great library of information out there for you. Some really brilliant people have provided this information from Salesforce. Go to the developer docs. Look at this. Check out the technical library. Look at your knowledge articles. These are the key things to know about Salesforce. Thank you, guys. And then open it up for questions. I'm available. John's available. So if you have questions, raise your hand and we can come up to the mic.
Got a quick question. Select count appears to be doing table scans, particularly when you're using the task object. Is there anything you can do if all you want to do is count the total number of tasks, including all the historical ones?
I don't, let's see, you want the historical all tasks. I don't think there's a great way for you to do that. Next question?
Anyone? Oh, sorry.
Yeah, I have a question. You said that a record type ID was indexed. What about when you use record type dot notation? So like record type dot name. Name is indexed on record type, so by transference, do you get is record type dot name indexed?
So when you're going to a related object, it's going to use that foreign key index to get to that object first. So depending on how your query is written, if the selectivity of your related object is greater than of the base object, the query optimizer may choose to use the index on your related object.
Okay, so I mean, would it be a best practice to always use record type dot ID in your filters rather than record type ID rather than record type dot name?
Yes.
Okay.
So yeah, just in general, you always want to be using IDs. Names can change. IDs are not going to.
Okay. And is there a way to scan for what SOQL queries are being used the most in Apex? You can do with event log files, you can see, which views are being loaded and which ones are taking longest, so it's an easy way to target those. But what about the actual SOQL queries and figuring out how many times those have been executed in Apex?
I think that's something that we potentially need to work on, because even in our internal logs, so you make you have a Visualforce page, we'll log that Visualforce page request, but we're not logging each individual query itself. So currently, we don't, even internally when we help customers, we don't have a great way, an automatic way to get a count of each query that's being run.
Okay.
If you're looking at reports, though, you can actually see the last report run date. Right. So things like that you can use to optimize your reports. So there are some helpers there, but for Apex, no.
Right. And then just one last question. In the demo, when you ran that last one, you got two entries, one that said 200 and one that said 20. What was the 21?
Yeah, so he's talking this.
Yeah.
Return the index on.
So you ran it for one query and you got two results. So what's the
Right,
difference
right.
and how do we
So
read that?
let's see.
It's because we use the order by and limit.
Oh, so I think your tool also needs to add, there's another field that comes back.
The fields.
There's a field called fields.
Okay.
And so for the index, it'll tell you what the name of that field was. So you might want to change that so that way you'll know which index it considered. So that's why it's hard for me to tell you exactly what it was, but it's probably the created date.
And it's
index.
because it has an order by and a limit as well. So
Okay.
that's going to help your query performance, which is
Yeah.
why you see the relative cost different than a table scan.
Gotcha. Thank you.
Yes. Sorry, I forgot to say. When you're running this query performance tool, you want to have a minimum 10,000 records in there or you're not going to get the right answer. So again, you don't want to run this in your developer orgs. You want to run this in your full sandboxes, or hopefully you don't test against production, but there's some people that do. You want to look at what does your actual data look like.
Right. I mean, the query optimizer will not consider some optimizations if the row count is so low, right? Because it realizes table scan, just get it all into memory. And the great thing about this tool is it's not actually running the query, right? So don't test in production, but you should be looking at production data. And this one won't be as expensive because it's actually not running the query.
Do you have anything to tell us about login history table? Any tricks, tips, secrets?
For login history?
Yeah.
Ooh, I haven't done anything with login history in a while.
Yeah, I rarely look at the login history. Besides, the tips and tricks about making sure, your filters are indexed as possible, or are as selective as possible, but nothing specific about, history.
Yeah.
Right. Anything else?
Awesome. Yes, they're up on the deck, and then they're up on the Dreamforce, and then they'll be putting the video up as well. And then it's also on the GitHub repository.
Quick question. Oh, sorry.